So I want to just do a couple of housekeeping things. API Craft Boston is, we're sort of revving it up and kicking things off at a higher gear this year, so I hope this turns out to be a useful session. I would love to hear from you guys about what you want to hear in these sessions, and if there's things that you want to suggest that we change, please let me know. This group has actually been around for a couple of years, but it's been in a lull, and now we're trying to really get it going again for 2015. We have our next meetup is April 7th. We have the LucyBot guys coming, so we've got Bobby over here. Andrew, sorry. They're brothers. So we've got Andrew over here. He and his brother Bobby are going to be here to present LucyBot, talk a little bit about visualizing APIs. They've got a really cool tool that they've built and just launched. So they'll show that to us, and there's usually a lot of discussion around these kinds of things. Tonight we're going to talk about microservices and APIs. We have Ian Goldsmith from Akana and Laura Heritage from Akana, who are going to present. And while Ian has a deck that he's going to go through, it's also very much an open discussion. So, please feel free at any point, get involved and participate in the conversation. I think everybody is, or at least a lot of us are just now kind of wrapping our heads around microservices. What does that mean to us? How do we implement that? What do we need to think about? The Akana guys have been going through this for a little while, so I'm really glad they're here to talk about this. And with no further ado, one thing to know is we are live streaming, so if there are comments or questions and it seems like it's a little hard to hear, I've got this handy dandy Rockstar microphone, so I'll walk around and make you talk into it. And is that my feedback?
That's me.
Oh, thanks, Ian. Awesome. Okay, so Ian's in the house. Okay, so I guess Ian's ready to talk, so I'll turn it over to him.
What gave you the clue?
So, and again, there's snacks and stuff, and there's more drinks, and so help yourself. This should be a nice, relaxed, there's a slide deck, but this should still be a nice, relaxed gathering, so please just get comfortable. All right? Thank you, Ian. You're up.
All right, thanks. Is this coming through the speakers okay? I guess so. I'll move around. Feedback? No? All right, we're good. Okay. So, first of all, thanks to the Smart Bay guys for hosting this and having us here. We appreciate it. Kind of any conversation at this stage about microservices is a learning exercise for everyone, including the presenter. So my goal is to finish as few of these slides as possible and to engage in interactive discussion as early as we can. It's going to make things a lot more interesting. So please interrupt at will, ask questions at will. Call me an idiot, I'm used to it, I'm married. As Lorinda said, I'm Ian Goldsmith, I'm VP of Product Management for Akana. It's still really hard to say that, by the way. I've been with a company called SOA Software for 11 years, and now I'm with Akana without changing my office location or any of that stuff. So it's going to be, I'm going to say SOA Software multiple times, so I may as well get out of the way now. So microservices, what I really want to talk about is what they are, why you want to use them, how you use them, series of things we're going to go through in this deck, getting on to some stuff at the end where I talk a bit about our own platform, not from a marketing or sales perspective, but from the way we've implemented the platform and how we're transitioning our own products to a microservices-based architecture. Also plugging my own blog. On blog.akana.com you'll find a couple of blog posts I've started to write on microservices and kind of building that out as a series. So we're trying to make that more interesting and maybe a little bit less enterprise architecture-y than some of the blogs, trying to keep it a bit more comprehensible. At least if I can understand it, then it has to be comprehensible. That's my theory. So what are microservices? There are a couple of different quotes from a couple of guys. Adam Cockcroft was the cloud architect at Netflix, basically responsible for running and operating the Netflix platform, designing that thing. And then Sam Newman is with ThoughtWorks, and ThoughtWorks has been putting a lot of thought into the enterprise architecture realm for quite some time, working with guys like Martin Fowler and James Lewis and guys who were the original definers of the microservices paradigm. Microservices on the surface sounds a lot like SOA. It is a form of SOA. It's a way of building applications using component services. You are componentizing an existing application in many cases, or maybe you're building a new application using component services to achieve a number of goals. But there are a lot of differences from SOA, and really it's a mistake to think of microservices in the same lens that you think of SOA. So we're really not going to dwell too much on what SOA is. Hopefully you guys know and understand the basic principles of services and service-oriented design. What we're really going to focus on is what makes microservices unique, and why microservices are sort of taking the industry by storm to an extent. Anyone here have a good understanding of what microservices are today? Okay, good. Some honest, some less so, maybe.
Hard to raise your hand when there's so many definitions.
Well, yes, right. It's hard to be wrong as well on that view, right? So, I'm going to get into how I view them and how I think they're designed. But really, I think the real thought process around it is driven by domain-driven design and bounded contexts. So the idea is that you're creating components of an application that align with product capability rather than project capability. So it's about the way that something needs to deliver a particular capability and ensuring that that capability is universally consumable by other aspects of the application. Ensuring scalability, reliability, designing for failure, all of that sort of stuff built in. We're going to get into the original definitive article on microservices and some of the 9 criteria that really drive them, but that's sort of the fundamental premise. And that actually brings along some very, very difficult things, particularly when you start thinking about the implication of bounded contexts on data separation. And we'll share more about our own path towards microservices and our own application, which kind of clarifies that. From a vendor perspective, particularly us, Akana, we're a software company. We build and own our own IP. We're not in the open source realm. So the predominance of open source stuff in this realm is hard. We're not fans of it at this point. Obviously, we all love open source. It's great, but not when you're trying to sell software that competes with the open source stuff. So it's also part of that kind of fundamental tectonic shift in the industry, away from vendor-owned IP towards community-owned IP. And we're seeing a lot of really kind of interesting things happening in the space, and not necessarily driven by microservices, but microservices are one of the beneficiaries of a lot of those kind of things. I think the thing that is freaking out most of the larger vendors about the microservices movement is that there's no middleware. It's easy as a software company to sell middleware. At least it's easy if you're Oracle or IBM or TIBCO. Microservices fundamentally do not have middleware. One of the driving design tenets is smart endpoints, dumb pipes. So you don't want intelligence in the network. You don't want to be making business decisions in the middle of your application. You want the application components doing their own thinking and figuring out their own infrastructure requirements and rules. And that's going to be one of the driving tenets that changes the way you have to think about it. And it's hard to kind of wrap your head around initially, the implications of some of that, but we'll get to it. Really just to kind of echo or highlight the open source nature of the microservices movement. This is the Netflix platform, Netflix reference architecture, which is now being taken to market by the Pivotal guys. Pivotal, Cloud Foundry, back end of IBM Bluemix, all that kind of stuff, spun out of VMware. And so all these tools are the things that Netflix used to build their architecture, build their platform. And Netflix, once again, is kind of pioneering a lot of this stuff. They're viewed as one of the visionaries in the way that the microservices architectures are reshaping the way things get built. I'm not going to go into what all of these things are. I'm happy to talk about it afterwards, or if anyone has any questions about stuff. I mean, there are some interesting things in there, like the Zool proxy is a client-side proxy, not a server-side proxy. So there are some pretty interesting things going on in this architecture. One of the more interesting components for those of us who've been in the SOA space is the registry idea. The registry in the microservices realm serves a similar function to the SOA or Web Services Registry, but this is not your grandfather's UDDI. This is something completely different, designed for near real-time publication and discovery of service location endpoints, and really it evolved out of key value pair discovery. So you need somewhere in your application to store stuff, to store configuration, to store basically information about the way the application is going to be running or is running at the moment, and the registry does that. The product that I like the most in that space, by the way, is console.io, which is well worth checking out. It's a pretty neat piece of technology. Okay, so to my top-level crass definition of what a microservice is, it is the intersection of SOA, DevOps, and containerization. And yeah, it's crass because containerization is basically a spin-off from continuous delivery, continuous integration. So you could argue that containerization fits within the DevOps realm, but I argue that it's got a lot of marketing buzz, so it's interesting, and it also makes a much better Venn diagram when you've got 3 circles rather than 2. So microservices is the bit in the middle. The thing that's really important to note, and I kind of highlight this on my most recent blog post, plug, is that it's not the overall intersect of everything. Microservices does not encompass all of SOA. It's not this vendor-driven paradigm involving ESBs and things like that. Microservices is a bit of SOA, and many people, myself included, would argue that microservices is the right bit of SOA, combined with the right bit of DevOps and the right capabilities out of the containerization realm. We're going to talk a bit about what each of these things are and more specifically what they're not. So which bits of SOA are the good bits and which bits of SOA are the bad bits? We could keep it really simple and say that the bad bits of SOA are the bits that involve the ESB. It's actually, again, it's a little bit of a broad statement, but it's not a bad way of thinking about it. The ESB is a piece of integration technology. It's something that evolved in many cases out of an EAI platform. In a lot of cases, it's the direct descendant of an EAI platform, or in some cases, it's still an EAI platform. But the ESB is something that has its place in the enterprise as a way you can expose a service from an existing application. But you shouldn't be trying to use it as a centralized piece of infrastructure through which you're routing everything. And unfortunately, in a lot of cases in the industry, people sort of say, well, my service doesn't do this thing I'd like it to do, and I don't really want to have to go and rev my application to make it do it, so I'm going to write a little bit of fancy stuff in the middle of my ESB, and I'll make my service do that. And that starts to extend. You add orchestration, you add more and more capabilities into the ESB until your application is built and running inside the ESB. Too much business logic, and it completely violates that smart endpoint dumb pipe premise. And there's a lot of other stuff going on in the SOA realm which isn't great either. The whole vendor-driven concept, the idea of registries, a little bit too much heavyweight governance, and I can hold my own hand up and say that we're probably a bit guilty of some of that. We have a particularly good heavyweight governance product. But in the microservices realm, the idea of governance is that it has to be distributed. It's distributed into the teams that are building the individual services or microservices. So that's kind of an important part. But it's critical to understand that microservices is really a reaffirmation of the core tenets of SOA, as in orienting the design of your applications around services and using services to expose core capabilities within that application. That said, microservices is not about reuse. That's a fundamental mistake to think of a microservices architecture as being a reuse-driven SOA initiative. It is not. Is it conceivable that some of the microservices you build as part of building an application are reusable? Sure. Should you be thinking about reuse while you're building them? Maybe. But that's not the core goal. The core goal is to architect your application correctly, one application correctly. We'll come on to talk more about that. Did I turn this off? Go back to the old-fashioned way. Thank you. So DevOps. Who here has a good understanding of DevOps? What it means? More. Okay, good. Good. The application of DevOps in the microservices realm is interesting because we're now talking about a single team that's responsible for the design, development, delivery, and operations and support of a component of an application. Gone are the days when the development team was responsible for development and maybe testing, and then they throw something over the wall and say, run it. The development guys were not the guys that got the call at 2 o'clock in the morning when it was broken. Well, in a microservices realm, they are. You have a team, and you'll hear a lot of talk about things like 2 pizza teams. You should be able to feed the team building a microservice with no more than 2 pizzas. It's supposed to be small. And that team includes the whole gamut of capabilities, including an operations person who isn't just responsible for running the thing. The operations person is responsible through the entire life cycle. You have to involve ops in the development of the platform, the development of the application, the development of the microservice. Because that team is going to run and operate and build that service completely independently of all the other parts of the application. Now, this is where, in large enterprise, particularly in financial services, people start looking at you wondering where you got that fantastic crack you've been smoking. Because it's hard to conceive of an application that's built of a series of completely independent components. It's really hard to think of a business application running over here and one team going ahead and revving part of it, completely independent of the other parts. And that's where you kind of get into sort of gated functionality in areas where a component of the application is able to function without another part, but when it detects that this other part is available, it can deliver more to its consumers. It gets kind of interesting when you start thinking in those realms. So the DevOps realm is really all about continuous delivery, continuous integration. It's about time to market. You're trying to iterate much more quickly around the delivery of the capabilities you have in your core product. You're trying to make sure that you can change things much more rapidly than previously. We're not talking about 6, 9, 12-month development cycles. We're talking about 2-week release windows for getting new functionality into the product, or even quicker in some cases. But the important thing to take away from all of this is the single team idea. And it's really hard to get this across, particularly in financial services, particularly in the UK, where I'm from originally, where people are a little conservative, and there's a whole attitude around that's more than me job's worth, governor. I can't possibly do that. Putting something into production, no. But it's changing. The world is changing pretty quickly. Is that working now? Yeah.
I almost broke my own microphone rule. So Ian, when you say team, so when people talk about, oh, that should be a single team, I think a lot of people interpret that differently. What do you see as the team consisting of? Is that dev and ops? Is that DevOps test? Is that, is a product manager in there? Like, who's in that team?
Yes. The product manager is probably the key question. Is the product manager a dedicated part of that team or not? All the other components have to be part of that team, depending on how big the team is. You may have a team that consists of one person who's responsible for design, development, integration testing, unit testing, deployment, operations, support. It's more likely that there are more people, but what you end up with is a much more diverse set of skills and diverse set of roles. So it's unlikely that there is one person that's the only person that knows Linux sysadmin skills for how to actually create an immutable Docker container and deploy it. It's likely that everyone on the team has a pretty good idea how all those things work, and everyone can do everything. Now, it's highly likely that there are only 2 people who can really crank out the wicked bits of code that are wrapped in the middle of the thing. But everyone probably has a pretty good understanding of how most of it works. So you end up with a much more flexible, more diverse team. But the team needs to include all those components. And the thing that always tends to get thrown under the bus in all of this is testing. And that's one of the beauties of this single team concept for the microservice. I mean, think about the typical development lifecycle, even in an agile realm, right? You've got a team that's cranking on 2-week sprints with a goal to put a release out every month. At the end of that second sprint, you've got 1 week left, and you're going, oh shit, I haven't done any testing yet. Oh well, I've still got functionality to deliver. Let's deliver the functionality, and I'm still going to put the release out at the end of this whole thing. So out comes the release, it's untested. But the development team doesn't care because they're handing it over to a bunch of operations guys who are going to run it. They care if they're the people running it and operating it. The attitude towards code quality changes dramatically when you're responsible for the totality of the product deliverable. It gets a bit more interesting. So the next kind of tenet in all of this is containerization. As I say, it's really part of the continuous integration, continuous delivery movement, but I think of it separately, in part because it's interesting. Anyone here got much experience with Docker? Okay. Anyone who hasn't got much experience with Docker, get some, because in the next 6 months, you're going to need it. If you are doing anything with virtual machines, you spend any time using VMware, that world is changing. It is all going to be Dockerized really, really quickly. And the main tenet in containerization is the idea that the images that you deploy are immutable. That means that you create a fixed image that is going to be identical between a development environment, a test environment, and a production environment. So theoretically, I can be writing code on my laptop, I can create the final image on my laptop, spin that same image up in a test environment, and then that exact same image will be spun up in the production environment, and they will all be identical. And that's a fundamental goal in the whole microservices realm, and it's essential for that single team model, the way that you run things out. Just to quickly explain the Docker realm, the containerization realm versus virtual machines, when you're using VMs, you take a single piece of hardware and you slice it up with a hypervisor and you drop multiple operating system instances on top of it. In the Docker world, you have that same machine, you run one operating system and you slice the operating system up into chunks. Much, much more efficient. It's much quicker to start the containers because they don't contain the operating system. They're much smaller. Beyond that, they share a whole bunch of components. So if I have one machine that's running 10 instances of the same image, all of the guts of the image are shared. Sure, the memory footprint's different from all of them. We're using different slices of the CPU, but the disk image is the same. And that's part of the rationale behind keeping these images immutable. You don't want anything on disk in the image changing. In fact, it should never be allowed to change. You could use external shared storage outside the image, but the contents of the image should not change. The only stuff that should ever change is in the memory allocation of that image. So Docker allows you to do some quite interesting things and to really speed up your DevOps process by defining your image content as part of your build process. So if you're using Jenkins or something like that for build automation, part of your build scripts will be to take a Docker file that you've used to define an image, create your final immutable image, and then spin it up through a series of test automation platforms. It's amazingly quick to do all this stuff. Sure.
Sorry, I can't read the slide. What's in between that host OS and the apps there?
On the left side? On the right. Binaries and libraries. I had to get pretty close to read it too, so you're forgiven. So yeah, the idea is that the host OS shares a number of things across all of the images. So if you look at the very basic image in a Docker realm, there's a thing called Core OS for the most part. A lot of people using Core OS anyway, which is a completely stripped down Linux variant. I mean, when I say completely stripped down, it has no root file system. You don't have bin shell, you don't have anything. So you layer a root file system onto that, and that will be shared across all of your containers. You layer a JRE in there, and the JRE would be shared across all the containers. Not the running instance of the JRE, but the JRE as stored on disk is shared. So Docker gives you a great deal of efficiency in that realm. So for example, in running our products in a Dockerized world, if we take a virtual appliance implemented using ESX, it's about a 2.5 gigabyte image with the operating system and all of our code. If we take the final immutable image for one of our gateway instances, it's about 70 meg, something like that. So it's a much more efficient way of distributing the product. Obviously, it's layered on top of a whole bunch of other things that you have to assume are there, but that's fine. Okay, so if you really want to get into the bowels of what microservices are, go read the Fowler and Lewis stuff. Just search for Martin Fowler microservices, and there's a great article. In fact, there's lots of great articles, but the seminal article is the one that'll come up at the top of the list in Google, and it's that one I've linked there. It's really good stuff. They write quite well. It's quite readable. It's entertaining. It's not going to put you to sleep. And it's educational. It tells you a lot about the principles and the core tenets. What I want to get into is a little bit of the trade-offs, things you have to think about, some of the core capabilities, some of the requirements for something being a microservice, and then the drivers. So why are people implementing them? We also want to get into some of the risks around it. So you have to think about things like Conway's law. Anyone? The idea that your application architecture is going to directly model the social structure of the team that builds it. First postulated in 1968, which unfortunately wasn't before I was born, but it was shortly after. So back in the very early days of computer science, this guy Conway came up with that idea, and it still holds true to this day. You think about the interfaces between the teams building the application, that models the interfaces between the components of the application. And so you have to be very careful when thinking about microservices, not to align your teams along organizational lines, but to align them along business functionality lines. So think about how your business is structured when you identify the way you want to build the application, I guess is the rule there. Talked already about the vendor-driven SOA idea, the whole ESB thing. Avoid it like the plague. That's sort of one of the main things you'll hear said over and over again in the microservices realm. Okay, so what are the 9 core tenets of microservices? Well, componentization via services. A lot of the service interfaces are trending towards REST. There's been a lot of talk about a ton of different models for the communication between microservices, but really there are two protocol stacks emerging as the choice of preference. There's just standard HTTP REST, primarily JSON because we're often talking about web-facing applications, and AMQP. AMQP as a messaging stack has some advantages for scalability. Of course, scaling HTTP is a well-known issue as well, and well understood discipline. You'll hear talk about things like CQRS. CQRS is not a protocol, it's not a standard, it's a way of thinking about separating the different classes of operations. So basically in CQRS you say, well, I'm going to have one service that handles my writes and another one that handles my reads, and I have to worry about eventual consistency across them. Why do I say you have to worry about eventual consistency across them? That's because bounded contexts define or state that each microservice must own its own data. And think about that for a second and think about the implication of that. That's quite scary and quite difficult to handle, particularly when you think about CQRS, because now I've got a service that's dealing with writes and another service that's dealing with reads. Well, okay, so I write to my service that's dealing with writes and it stores the result of writing it in its own data store, and then I immediately read from another data store. Well, how do I ensure the consistency across that data? So eventual consistency, it becomes a problem. That's the whole base model in NoSQL, and you see a lot of preference for NoSQL storage under microservices. Organize around business capability, so it's things like my user store should be one piece of functionality. Things like in the Netflix realm, the recommendation engine is a microservice. If the recommendation engine goes down, big deal. I can still use Netflix. I can still browse the catalog. It just doesn't tell me which movies I want to see based on what my 13-year-old daughter's been watching yesterday. I wish they'd turn that damn thing off a bit more often, to be honest. Smart endpoints, dumb pipes, we talked about that. Decentralized governance is actually, it's more difficult than you think. How do you handle governing what various development teams are doing in a decentralized manner? How do you track the overall state and health of an application, both from a development lifecycle perspective and an operational runtime perspective? It's not easy. These are hard problems to solve. The idea is that you have to put more faith and trust in the hands of your developers and less in the hands of your enterprise architecture teams and your IT organization as a whole, which is probably why all of the examples that we see today of microservices architectures exist in media companies and internet-facing startups and not in large financial services industries yet. That's going to change. It has to change because the efficiencies available through this kind of architecture are extraordinary. We talked about decentralized data and the fact that every microservice should own its own database. That's the rule in this list of 9 you're going to see violated more often than any other. And I should correct myself. Fowler and Lewis are very careful not to call these things rules. They call them criteria, but even then they correct themselves and say, well, they're not really criteria. We're just sort of laying out some guidelines. So these are things you need to think about when designing microservices. They're not hard and fast rules, and there are no hard and fast rules in this nice, soft, easy world. Infrastructure automation is key, and again, that's where Docker comes in. The ease of having multiple hosts in a Docker swarm, or using Kubernetes as Google does for clustering, a whole bunch of different technologies out there. In theory, you can take a single Docker swarm and have it host stuff on your laptop, on bare metal inside your enterprise, out on Amazon's container service in IBM Bluemix. All of these things offer Docker APIs to enable you to deploy images directly into them. And you could have an application distributed across all of them, which then, of course, raises a question around policy management. How do you determine which bits of your application must run where? If you've got a payment service as part of your application, it handles credit cards, you've got to be careful where you deploy it. It has to be in a PCI compliant environment by rule. So how do you deal with that kind of policy stuff? How do you handle that? That's a question that this realm has yet to answer. Designing for failure is key. How do I make sure that if something fails, the whole application doesn't go down? That's, again, another one of the core tenets. So, other guidelines, other things you want to think about. We talked about 2 pizza teams. Keep the team small. 2 pizzas is obviously just a guideline. You can get some pretty big pizzas, but you can also get some really little ones. So you don't need a lot of people building these things. If your microservice takes a team of 70 people to build it, probably not a microservice, I think is really what it comes down to. Single capability. That's really what micro means in microservice. Microservice is not a function of the size of the executable, it's a function of what it's doing. How much is it doing? What's it delivering? Someone just won. Lightweight protocol, so MQP, HTTP, you don't see much SOAP in the microservices realm. No reason you shouldn't, but we don't see much. And full life cycle, that's pretty important. And again, that comes back to the single team responsible for the whole life cycle of the application. Okay, so why are microservices? Yeah, sorry, go ahead.
Are you going to talk about distributed transactions and two-phase commits across multiple microservices?
I wasn't planning on it. We can certainly get into it maybe after the fact. Question was, am I going to talk about distributed transactions and two-phase commit? Part of the reason I don't really want to is because it's kind of a violation of no, it's not a violation of the microservice principle, but people in the microservices realm tend to think base rather than ACID. So transactional functionality across a distributed application in the microservices realm is difficult, and a lot of times it's simply not done. I can talk about how we do it in our application space when we get to the end of it, so I'll definitely remind me when I get to those slides at the end, which won't be too long, I promise. Why are they popular? Well, they're really popular because the old ways are unpopular. So your big monolithic application is slow, it's hard to manage, it's prone to failure. If one person's bit fails, then it brings the whole thing down. If you need to rev it, you have to rev the whole thing. That's the big issue. I've got a single giant application. It's at version 6.2.4, and I need to change the way I structure, or I need to allow people with a longer last name than 32 characters to sign up. Well, okay, I have to rev the whole application, deliver the whole thing. In a microservices realm, I can add one little ball to one of those services and do it really quickly. That's the primary driver. You add in scalability, you add in distributability, you add in high availability and other benefits that you get from some of the other things around microservices, and you start to see a lot of value. This is more a slide on why should you, on when should you, rather than how hard is it. So why should you use microservices, or when should you use microservices? You have to ask yourself 4 questions. Are you mature enough as an organization to do it? Is your trust in your development organization at a level that will allow you to succeed in microservices? Are you willing to re-architect the entire application? Now, at this point is actually a source of some contention between me and my CTO. I don't think you need to re-architect the entire application to adopt microservices. I think you can take one bit of it and deliver it as a microservice and leverage that as part of the large monolithic app. Alistair disagrees, but he's wrong. I'm here. He's not here. So I'm sticking with my guns. However, you must... You should, and he can argue. I'm coming too. You have to be willing to invest in the app. It's got to be strategic to you. You're not going to adopt a microservices path for something you really don't care about. It's a lot of work. It's quite hard. And I think the main thing is this bottom bullet point. The app has to require internet scale. Now, I mean, define internet scale, right? But the examples of where microservices are leveraged are companies like Google. They're companies like Netflix. These are applications that deal with hundreds of thousands of transactions a second. Do you need a microservices-based architecture if you're single data center dealing with 10 transactions a minute? Probably not. Is it worth the effort to invest in it to build that application out that way? Probably not. But if you think you may have an application that may need to grow and scale to those kind of levels that quickly, absolutely you should be thinking about building your application this way, because you really don't have any choice. It's very, very hard to build a monolithic application that scales this way. I should be clear, by the way, when I try and distinguish between the words app and application. An app being something that runs on your mobile device, and an application being something that runs in a data center somewhere on a big old server. I'm sure that's a purely arbitrary distinction, but that's the way I think about it. Okay. So, SOA, APIs, microservices. 3 terms that could all be considered to mean the same thing. They're certainly all derivatives of each other. They all have various different meanings in the same space. SOA is about reuse. It's about building common shared services within the enterprise that lots of different applications can leverage. APIs are about the way your application's going to be consumed. And in fact, most microservice-based applications result in the delivery of an API. So you think about Netflix. Netflix is an API at the end of the day. Yeah, there's a web app that consumes that API, but the Netflix application is an API. And same with most modern applications, they are an API. So that whole application is the API, API is the means of consuming the application, kind of means the same thing. So is the API a service? Sure. Does SOA result in services? Yeah. Does an API therefore have to be a variant of SOA? Yeah, sure. But it's still considered to be something a little different. And then microservices, yes, microservice is a variant of SOA. Yes, the result of that microservice application is likely to be an API, but there's an awful lot more to the microservices realm than just the services themselves. It's an architectural paradigm. It's a discipline around the way you build, run, and operate things, much more than it is about the service itself. Okay, so how much time do we have, by the way? How long have I been prattling on? Okay. Okay, all right, good. Okay, so what I am going to do, though, is skip very quickly through these next 4 slides, this one and 3 after it, because they're boring. And you can read them at your leisure later. But basically, you have to think about the considerations, the impacts on design, development, and testing. I'm going to stop on the 3rd one because it's less boring than the first 2. But so design, just basically, things have to change. You can't design in a vacuum, deliver to a development team, have the developers build it, have it send off to testing. Your SDLC has to become more integrated. Your teams have to become more integrated. You have to be more agile than agile. And I say that because in a traditional agile realm, you have spikes for design. You can't really do that in a microservices realm. You have to design as part of the implementation of a story. It becomes a shorter life cycle than even your sort of Scrum, Kanban, Agile type models. We'll skip the rest. The development team has to know more about the other components of the application than they might otherwise need to. So, and this is part of the microservices and not traditional SOA services discussion. You don't have, or you probably don't have, a UDDI registry. You probably don't have well-defined, well-structured interfaces for some of these microservices. There has to be a communication channel between the people building the consumer of a service and the people implementing the service itself. Is that going to change? Probably. We don't see Netflix having a design time registry or a repository or any design time governance that allows sharing of those interfaces. But I think in the enterprise we have to see something emerging around that. I think we'll see a repurposing of the SOA repository. And I use the term repository very intentionally because registry has become synonymous with the operational runtime components. And so we're focusing much more on how the developers have to find the things they're going to use and get more concrete information about those things. And it may be that that tool they use for that evolves to become the distributed governance component in the microservices platform. So testing. Testing changes. There's a lot of impact on testing. I highly, highly recommend that article on Fowler's blog on microservice testing. It's actually a presentation. It's well worth going through. I sound like a Martin Fowler groupie. I'm not really a Martin Fowler groupie, but he's just got some really good stuff. But the key really is that testing becomes part of the delivery. Now that sounds a bit strange, because am I saying that you should put untested code into production? Yeah. That's what canary testing's for. I'm going to identify a small set of my users. I'm going to deploy one particular instance of a microservice that's using the new stuff, and I'm going to ensure that this particular set of users is directed to that microservice. And I'm going to monitor really, really closely to see if the canary sniffs the coal gas and dies, or is it fine? So I'm going to use my real customers as part of my testing paradigm. That's the quote up here. It's a radical change in thinking. But there are a lot of more technical, more tactical implications on testing. If you're using console.io or etcd or Eureka as a microservice registry, the discovery component, how do your testing tools integrate with that? How do I ensure that the services that I'm rolling out in my test environment are discovered and are available to my consumers? How do I test that my client-side proxy, my Zool kind of thing, is working? How do I validate that it is identifying a new instance of a service and is using it appropriately? How do my test tools start to evolve to take care of that stuff? It's a challenge, and the thing that you realize really quickly in this space is that it's changing really fast. 3 weeks ago, console.io was unheard of. No one was really using it outside of the Netflix realm. Now it's become the tool du jour. 3 weeks ago, everyone was talking about etcd and Zookeeper. And now you say that in front of an experienced microservices guy, they'll laugh at you. The space is evolving frighteningly fast. Now, are you guys familiar with the Gartner hype cycles? They describe this thing where everyone gets... this way around. Everyone gets super excited really quickly about a technology, and then it sort of falls off the cliff into what they call the trough of disillusionment, and then it starts to inch its way up towards acceptance. Well, in the microservices realm, this hype cycle, hype cycles typically happen over a 5 to 10 year period. Microservices seems to be that it didn't start the hype cycle until about 6 months ago, and now it's already down through the trough of illusionment and starting back up the road to enlightenment. It's quite amazing.
Wait, Ian, before you move on, so when you're talking about testing, on a few of your slides you've said things like design for failure and build for internet scale and other things that make testers kind of cringe and wither and want to look for another job. And so you've got this whole slide here about it changes how you think about your testing. Mm-hmm. Can you talk a little bit about strategies? I know you and I were, sort of brainstorming some of this afternoon, but about strategies for testing for failure in a microservices world, because this becomes really tricky testing in some cases.
It does.
And you're doing it, before you answer this, it's tricky testing, and you're doing it in the middle of the dev cycle. So you're doing it as the team is iterating and deploying and, in a very fast-paced environment.
Yeah, I mean, let me just start by saying you're not throwing out unit testing, right? You're still doing all of the unit testing. You're still doing all of the functional testing. What we're really doing is adding a bunch of new components to the integration testing. So if you think about, well, let me describe the way that an application will typically scale in a microservices realm in a containerized environment. You'd have a microservice that delivered a particular piece of functionality, and it might be very small. It would have its own container. You can start them really fast. Let's say it's a simple web app. Each instance is a new Apache server that you're going to spin up. You've got a network load balancer, or realistically a cluster of at least 3 network load balancers distributed across your various different container hosts. You've got a distributed instance of the registry. We'll say it's console.io in this case. And then you use something, there's an application out that's kind of cool called Registrator. When Registrator sits on a Docker host, sees something deployed on the host, identifies that it's been deployed, publishes it to console.io. And that's all well and good, but what gets more interesting is that console.io has an agent framework and an eventing framework. So console can say, oh, I've got a new instance of web application X. It's running on port Y on host Z, and I'm now going to use my eventing framework to update my Nginx load balancer configuration to spin this thing directly into production. So that's kind of your environment. New things pop up, get dynamically automatically registered. Well, you need to check that they really are being dynamically automatically registered. So spin a new one up and ensure that it's being hit by your applications. Make sure it's really being added to the client load library. That's easy. What's much harder from an infrastructure perspective is ensuring that it's being taken out of the load balancer library when it dies. It's easy if you kill it intentionally and its shutdown process removes it from console and it's unregistering itself and doing all that stuff. If it just blinks out of existence, it doesn't have time to do all that unregistering. So something somewhere has to identify that it's not there and figure it out. Your testing paradigm needs to be able to take care of that. You need to be able to load test across that environment. You need to be able to ensure that you do get linear scale when new instances of the application pick up. You need to be able to identify weak spots and bottlenecks. So maybe 3 Nginx instances across your Docker host is not enough to load balance your application. You keep adding more instances to the back end, but your load doesn't go up. Well, maybe it's because your load balancers aren't there. Maybe your test tools can't generate the right level of load. So there's a lot of considerations to start to factor in when you think about all this, yeah.
You talked about load balancing a lot. Are these kinds of architectures you have in mind more compatible with these sort of lighter weight load balancers like an HA proxy, or are you referring to an application load balancer like F5, GTM, LTM?
Question is around type of load balancer more suited here. It honestly doesn't matter what kind of load balancer you use. The popular choice in this software-driven architecture seems to be software load balancers like Nginx, because they're dynamically configurable more easily and also cheap. And if you're running clusters of raw hardware with Docker hosts on them, and you can just pick 2 or 3 of your Docker hosts and run an Nginx engine rather than having to go out and buy a dedicated load balancer, then great. In a lot of environments that may not be enough, and you may want to use F5 to do SSL termination amongst other things. So there's a lot of choices. You start getting some really interesting questions when you look at the broader picture and you start considering, well, how do I do intrusion detection across a containerized application that's distributed across all these microservices? Is it okay to just do it at the front door? Do I need to do it in the back end? Security is a giant issue in microservices. You'll notice I have a master's in computer science focused exclusively on security, and that's the first time I've used the word, I think, while talking about microservices, because it's not addressed. The entire microservices realm is silent on security at this point. It's front door based security only. It's kind of like going back to the mainframe. But that has to come. That pattern has to come. But in terms of the question on load balancers, you can pick your poison really. But we're seeing more adoption of software-based load balancers deployed on the container host because it's easy, and the integrations are there with a lot of these things, and it's cheap. So cheap is the order of the day here. You can run tons and tons of containers on a single host, and they cost you very little to operate. So read the article and do your testing in production.
I was just going to ask for a follow-up on the security point. Like, why do you think that security is less well defined? Is it because you're not getting sort of, I don't know, RabbitMQ-based solutions that have queuing and data rest security that are involved, or is it just because it's so homogeneous compute plane that you're dicing up in different?
Yeah, the question really is why has security not been particularly well addressed, and is it because of the technology choices around?
Seems like it would be a function of architecture layers.
Yeah, I think it's a function. I think it's a function of Conway's law. Honestly, I think the development teams that are building the functionality are focused on the delivery of the functionality, and there's no overarching function looking at security at that level. And the types of organizations that have been driving the adoption of microservices architectures don't care that much about security. It's not that important to Netflix. I mean, yeah, there are some parts of their application that they really care about security. Their payment services, obviously, the way they bill you. But there's a lot of stuff that is wide open, and so it should be. It's designed to be. So I think that's sort of part of the issue. And I think also there's a growing assumption that security is endemic to the protocol. I mean, HTTPS delivers pretty good security, right? As long as you're managing your keys really well and distributing them effectively. Well, okay, well, maybe not then. The other thing that's kind of missing in a lot of these architectures is the distributed monitoring, health check for the application as a whole. Something we're seeing a growing adoption of is a pattern around the service endpoint having a number of different contexts. So you might have /service is your service, /status is it alive, /metrics gives you metrics reporting off it, and those kind of things. And as we see more of that, we'll start to see more use of distributed libraries for collecting metrics. There's some interesting stuff in the Google pattern and actually also in the Netflix stack for transaction tracing and those kind of things that you can enable. But monitoring and security and a lot of the non-functionals seem to have gone by the wayside a little bit. And it's very reminiscent of the early days of SOA, or actually, to be more precise, the early days of web services. SOAP is going to solve the world. SOAP, WSDL, UDDI, right? And everything's going to be great. That's integration in the internet. But what happened? Well, it never got adopted because of security concerns. And by the time the standards bodies wrapped their hands around security and made it so hard that no one could use it, technology had moved on. So I think security will get addressed in microservices more quickly than we expect. And the capabilities are there. They're just unstressed in the current writings in the arena.
Yeah, it just sounds like a structural problem. Like, it's up to you to decide what architectural layers you want to do.
Right.
The rest is just enabling you to do it. I guess on that point, do you see that when people are architecting their microservices solution? All right, I'm a rock star. Do you see when people are architecting their microservices solution that, let's say that they have 8 products as part of their overall application portfolio, they're delivering them all from the cloud, do they tend to swim lane their architectures so that you have like a full stack swim lane end to end with sets of microservices in each swim lane? I think we're way too early for me to even begin to try and answer that. I think the microservices-based applications we've seen to date are monoliths. They're evolutions of monoliths. They're a single application business in many ways. Like Netflix, right? Netflix does one thing. Well, 2 if you count the dying DVD delivery business, but that's Netflix has a single application that they deliver, and that was ideally suited to re-architecting along microservices lines. I don't think, so I may be assuming here, but it seemed to me like you were asking me about reuse. Are people considering services that are shareable across multiple applications in the business? I'm thinking that, well, a common way to create greater fault isolation would be to create a swim lane, right? So let's say that you have all your bare metal, and you have everything from gateway to application servers back to databases or NoSQL stores or whatever. And you're delivering product but everything's product as a service for you. And so what you're doing is you're creating a fault isolation layer for each one of your products, even though they're all working in concert or interacting with one another. So you have sets of services in each swim lane that are just for this product.
Yeah, I mean, I think at this point, the services are just for one product. But the underlying infrastructure services are shared.
Right.
So you're not going to build one set of container infrastructure for one application, another set of container infrastructure for another. Think of Docker as infrastructure as a service, basically. Well, it is infrastructure as a service.
Yeah.
So, you have one IaaS to run all your applications and microservices. You don't have to. Docker's not just for microservices, right? It can do double duty. But no, I don't think we're seeing that kind of thinking around. Even if I have common services, I'm going to keep them separate for different applications. We're not really seeing that yet. We might. Okay. So how do you get where you want to go from where you are? And I think I'll direct you back 3 or 4 slides to where I basically asked you the 4 questions you need to ask yourselves before deciding to adopt microservices. But assume you have a monolithic application, how do you evolve to get where you want to be and to microservice enable it? And yeah, I mean, the quote is valid. If you start with something bad, you're going to end up with something bad. So I can take your poorly structured monolith and turn it into a poorly structured microservices application very easily. We're trying very hard to avoid doing that. So let me talk a bit about our application. And it almost doesn't matter what it is, but at this point, it's an API gateway combined with a developer portal. We run it, we're a software company, we run it as a SaaS platform. We have multiple locations, but for the sake of simplicity, I'm keeping it to 2. So we'll assume that on the right is EMEA, which is hosted in Amsterdam. On the left is US East, which is hosted in Miami. We use Verizon's Terramark infrastructure for our stuff. Each instance has its own database. I've oversimplified. There's a 3rd location in play here where the databases are replicated constantly for a DR site. It's an active-passive environment, so that DR site is not up constantly. If we have a major data center failure, we have to spin the environment up in the DR site. It takes a few minutes, which gets us dangerously close to our running out of availability SLA space in our 4.9's SLA. The thing that's particularly notable about this environment is that each of these data centers host completely distinct sets of data. If you are hosted in our European environment and you start using our US environment, you're creating a new environment. They don't share data. It's not sort of one application distributed across the realm. And out of these 2 separate applications, we currently expose little more than 40 APIs. I actually checked today, it's 43. 43 services exposed out of these things. A bit misleading to show them just across the top because they're really between the 2 applications as well. We have a web client that sits on top of this thing that is a single web page application, JavaScript running in the browser that consumes this thing. And it consumes a number of those APIs. The APIs are also all tied together in the middle for linking these things. So that's essentially the current architecture. Now, it has a number of challenges. The geographic scaling is difficult. High availability is difficult. The manageability of the application is a challenge. We have to rev the whole thing at once. We could theoretically put a new version of the developer portal into the cloud, but they tend to be quite tightly tied to the API versions exposed out of the gateway. So it's a bit challenging. I say now, that's not quite now, that's actually about 3 months ago. Now and over the, sorry.
Oh, when you said you had 40 APIs there, do you roughly think about one API as being one microservice? Go something what that one API
Yeah. Ideally, each of those APIs would probably be a microservice. At this point, each API represents a piece of business functionality. So for example, in the developer portal, we have a piece of functionality for forums. So it's like a Facebook wall kind of thing. You can post and communicate around a particular API. That's called we call it a board. It's a forum. That's one API, one service in this realm. And then there's another service, another API for users. There's another API for APIs. It's an API management platform. There's an API for apps. So each of these things has an API, and there's a ton of them, about 43. So yes, ideally, they do each represent a piece of discrete business functionality, and ideally they'd all be microservices. So where we are halfway through taking this is towards an architecture that changes things a little bit. Actually, I have to go thump my graphics guy for getting a word wrong here. The big databases should still say, in the middle should still say database or SQL. They're not NoSQL. We've introduced the idea of NoSQL storage from one of the applications that we've broken this thing into. So one of those applications is a monitoring and metrics data collection application, which as of about 2 months' time, will be storing all of its collected data in a NoSQL store. That application will contain about 6 of those APIs, so things like collect metrics, collect roll-up data, various ways of requesting that data and slicing and dicing it. So that application we're calling the management application. There's a security application. There is a scheduled jobs application. There's the developer portal application, and there's one other, I can't remember what it is. But basically, breaking up that current monolith, or those current 2 applications, into 5, and pulling out some of the data so that one of those applications owns its own data. This is not microservices, but it's a step in the right direction. It's getting us a little bit closer to being able to do that. At the same time, we're introducing some fairly sophisticated sharding and replication capabilities, even between the SQL data stores, so we can deal with the geographic distribution and active-active deployment much more effectively. So with this architecture change, we get to a realm where we're able to deploy the application in multiple data centers and have the European guys share a portal with the North American guys and have a more consistent approach. It's difficult to manage because we start having to think about sharding across the application. We have to start managing multiple different data stores. It gets very, very complicated. So where we want to get to is this, where instead of being 5 different applications, we have each piece of business functionality delivered as a microservice. And the hardest step here by far is going to be getting rid of all those single data stores and replacing them with individual data storage for each microservice and each instance of each microservice. So if we've got 5 running instances of our users service, each one of those needs to have its own data store, and they need to be responsible for replicating and managing the consistency and managing their shards. What you end up with when you go down this architectural path is sharding is managed at the application level. So the microservice itself is responsible for maintaining the sharding infrastructure. You don't rely on the data store to do that for you. So you start having to rebuild some of that logic in your own microservices, and there's really no way to avoid that in order to ensure the kind of distributable capability that you want to get into. It's easy locally, it's much harder across large geographic boundaries.
Do you get into the mode where if you actually have to maintain some consistency, you have to serialize?
Well, the question was if we get into the mode where we have to maintain consistency, do we have to serialize the transactions? No. What we're doing is we're actually using, we're basically putting an aspect into the data layer so that when you take a write in one microservice instance, it writes to its own data store, and as part of that commit, it also writes the update to a shared queue, or a topic to be precise. And then every instance of that microservice subscribes to the topic. And so in order for a microservice instance to be allowed to write to the data store, it has to have flushed everything out of the topic that it's due to flush. So it can cause, I don't know, in some cases as much as a second or 2 of delay to a write operation. So a user may have to sit there looking at something spin while they're trying to wait for something to write. So maybe I'm trying to post an update to a forum. It might take a second or 2 to make that update in some instances. For the most part, it has negligible impact on the performance of the application. But that's the approach we're taking. So that's how we're kind of doing distribution at the top level. We're a bit smarter than that in that it's also using a sharding approach, so it basically recognizes, okay, this user is primarily US-based, they're primarily US East-based, so we'll essentially keep their primary data storage in the local store, and we'll replicate that out to that realm. We hope to get here probably in about a year. It's not a quick process getting from where we are today to this approach. But the benefits of getting here will be quite significant, both for us operating our own SaaS platform and for our customers who are deploying our product on premise. It gets into an interesting conversation as a software vendor, though. You have to start looking at your stuff and say, well, are any of our customers going to be as big as we are? I mean, we're our own customer, and we use the hell out of our software. Right? We've got a lot of people using it in a SaaS platform, pushing probably multiple hundreds of thousands of transactions a second through the platform. I think our largest single customer is probably at about 4,000 transactions a second themselves. So we're our biggest customer by a massive margin at this point. But all of our customers are driving us down this path. They want to be able to take this kind of architectural approach because they want the control over how they'll scale the application. They want that kind of HA capability. So the final step in this picture is really the last sort of result of the thing, where you look at the implications of Dockerization and you start thinking about, well, how many container hosts am I going to have? And which microservices will I deploy on which container host? And then you start getting into like Docker Swarm and Compose and various other techniques and technologies for how you scale and how you roll out in that kind of manner. Interestingly enough, in our world, we're Dockerizing before we microservice enable. So when I go back to this picture, each of those applications is a Dockerized immutable image. So we can spin them up quickly and reliably as part of our DevOps environment. And we're adopting a lot of the principles of microservices here in that we are going to small teams responsible for their own piece of the application. The teams will be able to rev parts of the application independently, except for anything that affects schema, because anything that's shared in the middle, and that's actually probably, I skipped the hardest part of the whole thing. In this realm, there's a lot of joins. So how do I do permissioning on who can write to a particular forum object? Well, there's a join across the users table and the authorization tables. When you move to a microservices approach where all of those services are independent, your joins have to be done in the application, not in the data layer. You've really got to think about it. And there are some functionality that becomes quite difficult to deliver, and you have to get very creative. And fortunately, we've got a lot of people who are way, way smarter than I am who can think about that, because my brain hurts the moment I start trying to understand that. Joins are hard enough in a single database. And with that, I think I'm done. Questions, comments, feedback? Throw me out, buy me a beer. Yeah?
So Docker, it hasn't been around for too long. You know, everything's moving so fast. It's a new open source.
Uh-huh.
Quarter, month.
Yep.
I've heard CoreOS, you mentioned CoreOS, which is stripped down Linux. I've heard that they're moving away from that.
Yeah. Yeah, there's Rocket. There's a lot of different technology out there. At the moment, Docker has all the mind share, and they're doing some really, really smart things. They picked up Fig and rolled it into Docker as Docker Compose. They're rolling out Swarm. Docker is going with Machine, which is their kind of model for rapidly deploying Docker containers. They're making a lot of very smart decisions. Personally, I'm not convinced on their business strategy of Docker Hub Enterprise being the way they plan to make all their money. So the idea right now with Docker is you've got Docker Hub, which is a cloud-based image repository, and you can start any image from Docker Hub locally. The idea is that in the enterprise, they want their own image repository, so what Docker's going to do is make their money selling Docker Hub Enterprise. I don't know that there's enough money to be made doing that, but maybe. Who knows?
Do you know much about Rocket?
No. No, all my experience has been on my laptop with boot to Docker and various different scratch minimal image bases. You had a question?
Yeah. How are you guys orchestrating these containers? So we had some trouble dealing with hooking different containers up, exposing the images to one another, so that they can have, we tried different techniques of, exposing ports on the host and mapping the ports. What did you guys do there?
It's really hard. The question was, how do we deal with orchestrating the containers and the images, and how do you kind of wire it all together, basically, right? So I'll give you the particular problem we face, which is that going back to this, the API gateway instance, it's an API proxy, and they're entirely stateless. So what happens is the instance starts, our product starts up. It's an OSGI container, so it really starts in 3 phases. The base container comes up, and it's doing nothing. Then it starts all the application bundles in the container, and the application bundles finish starting. Now, at that point, you think you're done. No, because what it then does is it reaches out to its central repository, and it says, hey, what am I responsible for hosting and running? It gets a list back of all the services that it's responsible for hosting, and then for each of those, it goes and gets the descriptor language information, the policy information, and it hosts them one by one. And in a large environment, like in our SaaS platform, we've got, we shard across the containers, but we've still got containers hosting a couple of thousand APIs. And it can take 5-6 minutes to start a single container as it goes through that startup process. Now, a little earlier I talked about the model where you use a combination of registrator and console and Nginx. So registrator sees the Docker container start. It says to Docker, oh, what's your dynamically assigned port for this application on this host? It registers that in console eventing, fires it into Nginx, right? If we tried that with our model, we'd have a real problem, because the Docker container would start and it would immediately assign a dynamic port the moment our OSGI container came up, because the OSGI container would say, I'm here on port 9900 or whatever it is. Docker would assign a randomly assigned port. Registrator would pick it up, stuff it into console. Console would stuff it into Nginx. Nginx would start routing to our container, which wouldn't be ready. It wouldn't know any of the context it's supposed to be listening on yet. So we have to break that model, and we have to say, okay, we're not going to use registrator here. We're going to essentially put an API in our product that allows us to detect when it's completely started, an eventing mechanism, and say, okay, when completely started, run the script. And that script then does essentially what registrator does, and pushes it discovers the Docker assigned dynamic port and pushes that into console. So does that kind of answer the question?
Definitely. And then you're using the health check script in console to detect when this thing goes down?
No, we're actually using our own, we have our own capabilities around that inside there's a central management component in the gateway, and that is able to detect when one of its instances is down and take it out of the load balancer pool. So we haven't polished that last piece up yet. It needs a little more work, but that's where we're going. I think that's one of the hardest problems. It's really easy in super lightweight web applications. That's kind of the goal, right? Each microservice should be able to start in milliseconds, but they don't, unless you're really lucky, or you've architected it in a really lightweight way, or it doesn't do anything.
I guess a follow-up question, but it's a bit of a segue. But when I assume you have different caches at various different layers going on here. You had talked about the importance of separating microservices so that they all own their own data. When, let's say, you have 2 services, A and B, and A is going to pull some data from its database and for performance reasons and cache that data, and B needs access to that data, do you have a situation where you have B accessing the cache of A directly?
No. So we could use console for that shared cache, right? Console is like Zookeeper or etcd. It's a centralized distributed, bit of an oxymoron, but it's a distributed data grid effectively for key value pair storage. We don't, because we've embedded an in-memory data cache called Hazelcast in our platform. So it's a UDP-based sharing mechanism. So each instance of our product owns its own shard of the Hazelcast shared cache. Our problem actually is far more severe than caching of stuff you need for performance optimization. It's nonce caching. We do a lot of security processing, right? So if we receive a signed request from one gateway instance, we have to immediately add the nonce from that request to the shared cache, so that if someone tries a replay attack by sending the exact same request to another instance of the gateway, we can detect that it's a replay attack. So we use Hazelcast to deal with that.
So it sounds like you're using a cache to share between like instances of a service.
Correct.
Between heterogeneous services, can they use each other's caches?
They can. I mean, again, so in that realm, the heterogeneous instances could use, we publish the SDKs for Hazelcast. We publish Hazelcast as an API, so they could use the Hazelcast grid, but I wouldn't recommend that. In a microservices realm, if you want to have heterogeneous applications sharing data with others, there's lots of different ways of doing it. Probably the emerging best practice is to use the key value storage in the registry. So use console, use Zookeeper, use etcd, something like that.
So you're using Hazelcast. Are you using the properties of Hazelcast just for sort of data partitioning, or are you actually creating microservices in Hazelcast?
We're not creating microservices in Hazelcast. We're using Hazelcast purely as kind of like a memcached, basically.
Okay.
We're really just using it as an in-memory distributed data grid.
Do you have a position on whether or not you should create and use the grid compute capability in Hazelcast?
I don't really. I haven't put enough thought into it. I think Hazelcast would be a great candidate for running as a microservice rather than as part of another microservice, and then use something like Hazelcast distributed across your various Docker hosts, providing that shared cache capability. But I'm not sure if that's what you mean. Do you mean running Hazelcast as a microservice, or?
Well, Hazelcast has the ability that you can put your Java process.
Oh yeah, no, we don't do that. No. We're not. We're not. We're trying to keep it single purpose. As far as we're concerned, it's just a distributed data grid, distributed data map. Anything else? Go ahead.
All right, one more question, sorry. I can go all night. Looking at your architectural migration, did you have monolithic like, I'm wondering if you started with what looks like a shared kernel that you have to break up to get to your microservices implementation. Am I reading that right?
Yeah, so up until, it's kind of an interesting story. The product is relatively old. The first version of the product was 2002. And it consisted of 4 standalone Java applications. So four Java processes that ran, that delivered 4 separate components of the application. We brought it all together into one in 2006 when we adopted an OSGI model. So we deploy an OSGI container, and then we have a whole bunch of features that you deploy, and they're packaged as, a whole bunch of bundles you deploy which are packaged as features. So you can theoretically say, I only want this bit of the application or this bit or this bit. But in reality, the guts of the thing all kind of had to run on one container. There was too much dependency between them. But each of those OSGI bundles exposes a set of services. That's the OSGI architecture pattern, right? It's Spring DM, and you define a set of services. So now with the microservices approach, we're taking those OSGI services and are surfacing them as individual applications one by one, and sort of working on breaking it back up again into different pieces. Interestingly enough, we have a few customers actually who are taking our OSGI container, which is relatively lightweight, deploying it in its own Docker container, and using that as the foundation for deploying and building applications. So they're basically taking a Dockerized version of our stuff and using that like a PaaS instance, effectively. So you've now got this thing that, because the nice thing about our base container is it does all the web service framework, and it's got JAX-RS, and it's got a data access layer, and it's got a MongoDB instance for NoSQL built in. It's got a whole bunch of stuff that it delivers that's valuable to the developer. So you can build really small, lightweight applications as a set of, or even a single OSGI bundle, and have at it. We also can go a step further than that. The API gateway component has a script engine in the middle of it. So you can create applications in Node and run them in Nashorn inside the container running inside OSGI. So it's got a number of nice capabilities like that.
I have a question.
Yeah.
Are you aware of any tools for doing kind of a testing where you want to find out if you don't have enough load balancers, or kind of figure out what would happen if one of your microservices goes down? Are there some open source tools to get people started?
Not that I'm familiar with, but I think we're in the right building to talk to the people that might be able to create something or deliver something in that area. I'm not, testing is not my forte. You can just talk to our QA guys. They'll tell you that I'm the guy that always tells them to, shh, let me release it. Hazard of product management. We're looking for time rather than quality, I guess. So no, I don't know, sorry.
So just, so we had a great conversation on making zero promises about this, but, you know, we make SOAP UI API testing tool, and so we've been having conversations actually with Ian about what would be cool to do in that tool for microservices. We don't have that yet. But you should look at the Simian Army. Are you familiar with the Simian Army? So Netflix has built a whole bunch of open source testing tools. Yeah. And Chaos Monkey is, you know, when we were talking about design for failure and test for failure, Chaos Monkey is great for if you have the balls to run it, go for it. But they've built a whole bunch of really great tools for that kind of thing. All open source.
I think I'm done.
You are amazing. Thank you. Your
Thank you.
endurance is incredible. Thanks, everybody. I hope this was great. Feel free to grab whatever else you want from the kitchen, whatever's left in the kitchen. Don't forget, April 7th is our next one. So we've got the LucyBot guys coming to go through their tool. We'll talk about visualizing your APIs a little bit in that one. And onboarding developers, so they've built a great little cookbook generator. So just keep an eye on the meetup, and thank you all very much.
Thanks a lot, guys. Thank you.